And yeah, I'm not sure whether we should draw lots before lunch or we can do that after lunch. Maybe we should draw lots before lunch so that the teams know which group they are in. Okay, yeah, we can do that. Do we still have the balls ready here? We have. Great, excellent, yeah. The balls are ready, yeah, okay. Okay, here we go. You test the bells? Yeah. Yeah, we'd like to welcome especially a new team from Iran all the way. How long did it take you to travel?
About 24 hours.
24 hours, right. Thank you. Okay, your question is, at the prolonged depolarization of cardiac muscle, what are the two opposing ionic fluxes? At the prolonged depolarization of cardiac muscle, what are the two opposing ionic fluxes?
The calcium ions and the potassium ions.
Do you want to describe the fluxes?
The influx of calcium ions and efflux of potassium ions.
That's correct. Okay, two answers. If the plasma potassium is 3 millimole per liter, state the location of the sensors that detect this, 1. And 2, the hormonal compensation that will occur. Let me repeat. If the plasma concentration is 3 millimole per liter, state the location of the potassium sensors that detect this and the hormonal compensation that will occur.
The sensor will be in the adrenal cortex and the compensation will be inhibition of aldosterone.
That's correct. Okay, your question is, during physical activity, state the hemodynamic change to 1 regional circulation that accounts for the slight increase in diastolic blood pressure compared to the increase in the systolic blood pressure. During physical activity or exercise, state the hemodynamic change to 1 regional circulation that accounts for the slight increase in diastolic blood pressure compared to the increase in the systolic blood pressure.
Okay. Which region? I'm not able to get the question.
Sorry?
Not able to get the question.
Okay, one last time, listen carefully.
Hemodynamic changes in.
Wait, I'm going to repeat the question for you. Okay, listen carefully. One last time. During physical activity, state the hemodynamic change to 1 regional circulation. 1. That's why I said 1. You don't have to give me 2. Give me 1. Okay, 1. 1 regional circulation that accounts for the slight increase in diastolic blood pressure compared to the increase in systolic blood pressure.
During exercise,
Yes.
The muscle will constrict will dilate, the vessels in the muscles will be dilated and the vessels in the other parts will be constricted.
Just 1. We just want 1. So just simplify your answer.
So overall there will be decrease in peripheral resistance.
Okay, okay, your answer is correct. Yeah. Yeah, so it's skeletal vasodilation and decrease in TPR. Yeah, okay. Question 4. How does the direct action of excess plasma mineralocorticoids alter blood pH? How does the direct action of excess plasma mineralocorticoids alter blood pH?
Excess plasma mineralocorticoids cause excess secretion of H plus ions, therefore it causes alkalosis.
Yep, that's correct, yeah. Okay, your question is, how does deficiency of surfactant affects the intra-alveolar pressure in two different size alveoli that are connected? I repeat, how does the deficiency of surfactant affects the intra-alveolar pressure in two different size alveoli that are connected?
Sorry, can I clarify? So there's one smaller size alveoli and there's one larger size alveoli. Then they are both connected, but there is a lack of surfactant. Okay, so and you want to know the change in intra-alveolar pressure?
That's right, yeah.
Like separately for the smaller one and the larger one?
Yeah, yeah.
Okay, so for the smaller one, for both of them, the intra-alveolar pressure would be decreased. Since they are connected and there's a lack of surfactant, there is an increased collapsing force for both the alveoli.
Answer is wrong. Yeah.
The smaller alveoli, the intra-alveolar pressure becomes higher.
Slowly.
In the smaller alveoli, due to lack of surfactant, the intra-alveolar pressure becomes higher, which causes air to go from smaller to larger alveoli, and it further decreases the radius. So again, the pressure becomes higher and higher in the smaller alveoli.
Okay, that's correct. Yeah. It's the intra-alveolar pressure in the small alveoli is actually greater than the one in the larger one here. Okay, check your bells. Okay, your question, BPUMS. In dumping syndrome, state how a change in a hemodynamic parameter triggers a change in an autonomic neural associated symptom. In dumping syndrome, state how a change in a hemodynamic parameter will trigger a change in an autonomic neural associated symptoms. No? Sorry? Oh, you don't know the answer? Okay, he's opening up. Anyone can press now, yeah? Yep.
In damping syndrome, there's decreased absorption of glucose. So there's hypoglycemia, and therefore there will be increased sympathetic activity.
Answer is wrong. Yeah. So we wanted a hemodynamic parameter, not a change in the glucose. So the answer should be hypovolemia and triggering sympathetic activation. Yeah. Okay. The other phase, the other contribution is hypoglycemia, but we wanted the hemodynamic change. Okay. Answer is wrong. Okay, here you are. Second question. State the specific two countercurrent flows related to the function of the juxtamedullary nephrons and the vasa recta. I repeat. State the specific two countercurrent flows related to the function of the juxtamedullary nephrons and the vasa recta.
Urea and sodium influx in the ascending vasa recta, and there's a water efflux out to the interstitium.
Answer is wrong. Yes.
There's countercurrent multiplication at the loop of Henle, causing the generation of the cortical papillary gradient, and countercurrent exchange at the between the ascending and descending vasa recta to maintain the gradient.
Wait. Sorry. We just want you to tell us the countercurrent flow.
Between the descending and ascending loop of Henle and descending and ascending vasa recta.
That's correct, yeah. So the countercurrent flow is not between the vasa recta and the tubules. There are two countercurrent flows, countercurrent blood flow and countercurrent tubular fluid flow. Yeah, okay, thank you. So next question, what are the two opposing forces that contribute to the equilibrium potential of chloride? What are the two opposing forces that contribute to the equilibrium potential of chloride?
The chemical gradient of chloride. Chloride is more outside the cell than, and the electrical gradient because the inside of cell is negative as
That's
compared
correct, yeah. So it's a calculated balance between the chemical and the electrical gradient. Okay, question 4. Okay, you asked, I'm going to give you a statement. You have to state if you agree with the statement and give a short, as brief as you can, okay? State with reasons if you agree with this statement. The sodium-potassium ATPase has an insignificant contribution during an action potential. State with reasons if you agree with this statement. The sodium-potassium ATPase has an insignificant contribution during an action potential.
The sodium potassium ATPase contributes to
Wait, do you agree first?
Yes, it makes an insignificant because it is the chemical gradient which it directly contributes is the electrical gradient which it directly contributes.
Slowly.
The contribution can be said to be insignificant because the sodium potassium ATPase directly contributes to only 4 millivolt of electrochemical gradient of the electrical gradient, but it also maintains the ions, the ion in the equilibrium concentration. So indirectly, it has a significant effect.
Thank you. Answer is correct. Yeah, the direct contribution of the sodium ATPase is less than 5%. It's actually very small. Okay, the fifth question in the second cycle. In primary adrenal insufficiency, state the change in the associated hypothalamic and pituitary hormones. In primary adrenal insufficiency, state the change in the associated hypothalamic and pituitary hormones.
Both the hypothalamic CRH and the pituitary ACTH increase.
That's correct, yeah. Okay, we are into the last cycle of the last session. Okay. Two short answers. State the location of the signals that initiate the primary peristalsis, and 2, the secondary peristalsis in the esophagus during a meal. State the location of the signals that initiate 1, the primary peristalsis, and 2, the secondary peristalsis in the esophagus during a meal.
I think for the first one is in the 1/3 upper part of the esophagus, and for the second one will be the entire part of the esophagus, mostly at the middle, and the 1/3 in the middle, and at the end.
Sorry, could you repeat the answer again?
Okay, for the first one, at the 1/3 upper part of the esophagus, and for the second one, in the entire esophagus, and mostly in, I think, in the 1/3 middle of the esophagus, and at the end.
Answer is wrong. Okay.
For the primary peristalsis, since it's an involuntary reflex, I think it comes from the medulla oblongata. And for a secondary peristalsis, it comes from the esophagus.
That's correct, yeah. Yeah, the primary signal comes from the swallowing center, medulla, and the secondary paralysis is triggered by the enteric nervous system in the esophagus, yeah. Okay, second question. State, okay, two answers here. State the external pressure which is used to calculate the transmural pressure in one, the airways, and in two, the alveoli. State the external pressure that is used to calculate the transmural pressure in one, the airways, and in two, the alveoli.
It's your negative interpleural pressure.
For the first one?
Oh, no, I'm sorry. For the first one, that's between the external pressure for the
Airways,
airways,
and the alveoli.
airways and the alveoli. For the alveoli, it's your interpleural pressure. For your airways, it's your thoracic chest wall pressure.
Answer is wrong. Yeah.
For the airways, it is intrapleural pressure, and for the alveoli, it is also intrapleural pressure.
Yes, it's both the same pressure, yeah. So both the transmural pressure is just internal and external, yeah. Okay, question 3. State the chemical change that occurred to filtered bicarbonate at the proximal convoluted tubule. State the chemical change that occurred to filtered bicarbonate at the proximal convoluted tubule.
At the proximal tubule, protons are secreted by sodium hydrogen exchanger, which combines with bicarbonate to form carbonic acid, which dissociates to form CO2, and it is absorbed. And within the cell, it forms again bicarbonate, which is absorbed.
We don't want to know what happens in the cell. State the chemical change that occurred to filter bicarbonate at the proximal convoluted tubule. Yeah.
Bicarbonate combines with the secreted protons from the proximal tubule and forms the carbonic acid, which dissociates into water and CO2.
That's
CO2
correct.
is absorbed.
Yeah, that's fine. Okay, your question is, okay, state the mechanism for the abnormal intestinal muscle contraction in primary hyperparathyroidism. State the mechanism for the abnormal intestinal muscle contraction in primary hyperparathyroidism.
In primary hyperparathyroidism, there is greater calcium absorption in the intestine, which leads to abnormal contractions.
Sorry, there is abnormal calcium?
In primary hyperparathyroidism, there's an increase in absorption of calcium from the intestine, and this leads to the abnormal contractions of the intestine.
How does the increased calcium absorption causes abnormal intestinal muscle contraction?
Because the calcium channels are required for the spike potentials. Calcium ions are required for the spike potentials, which is necessary for contraction.
Answer is wrong. Yes.
In primary hyperparathyroidism, there's hyperkalemia, which decreases excitability and that decreases motility of the intestine.
That's correct, yeah. Yeah, the high calcium in hyperparathyroidism reduces the both nerve and muscle excitability. Yeah. Last question in this cycle. Okay. For the two photoreceptors, okay, we are finishing round one. For the two photoreceptors, compare one, their sensitivity, and two, their convergence in neural connection. For the two photoreceptors, compare one, their sensitivity, and two, their convergence in neural connection.
Sensitivity and convergence.
Yeah, sensitivity and convergence, that's right.
The rods are more sensitive and
Rods are more sensitive.
greater convergence in the cones.
Louder, louder.
There's greater convergence in the cones.
Greater convergence in the cones. Answer is wrong.
There is convergence in the rods.
Slowly, slowly.
There is convergence in the rods and the cones are more sensitive.
There's convergence in the rods and
There's convergence in the rods and the rods are more sensitive.
what is more sensitive?
Rods.
Correct. Okay, yeah, the greater the convergence, it's not a one-to-one, yeah, so rods are more convergent. Okay, we have, so please, you can go down to the stage while we summarize the results for round one. Yeah. So the winner in this team is, yeah, I can't see, yeah. Is 11, 10. Okay, is New Delhi, is it? AIMS, AI, yeah. From New Delhi, All India Institute. Okay, and we will wait for the scores here.